Have you ever had a report that shows yesterday's data even though you know it was created today? Or worse, users keep asking why their meeting times are showing up 10 hours off. These kinds of issues in SQL are sneaky. They don't break things loudly, they just give you the wrong results, and that's even worse. In this video, I'll show you the right way to store and manage time zones in your SQL database across Oracle, SQL Server, MySQL, and PostgreSQL, so you never have to debug these problems again. And if you want a cheat sheet with all the right data types and conversion functions, there's a free one linked in the description. Let's get started. Time zones don't just annoy the developers, they can also break things. Meetings and events show up at the wrong time. Reports include or exclude the wrong data. You get weird gaps and overlaps during daylight saving time. Here are the 3 key problems you need to solve. First, time zones vary by region. Sydney, London, and New York are all different. Second, daylight saving time changes things, which means a time like 2:30 AM might not even exist. Finally, every database handles time zones differently, so the same code won't work everywhere. Let's start with the golden rule. If you only remember one thing from this video, it's this: store all timestamps in UTC, always. Why? Because UTC doesn't change with the seasons. It's consistent across servers and regions, and it makes comparing and sorting dates easier. When you display times to users, you can convert the UTC time to their local time in your app, but you should store everything in UTC. Let me show you how to do this in each database. We'll start with Oracle. To get the current date and time in the UTC time zone, you can use the systimestamp function, then add the keywords @timezone after it, then UTC. In Oracle, you'll need to use the from dual keyword if you're not selecting from a real table. In recent versions, I believe this is no longer required, but in either case, you can use the systimestamp function here. For SQL Server, you can use the function getUTCDate. You don't need any @timezone keywords. In MySQL, you can use the function UTC_timestamp. This will also get the timestamp at the UTC time zone. Finally, in Postgres, you can use the now function and then the keywords @timezone, then UTC. This is similar to Oracle. All of these functions give you the current UTC time. You can use these in insert statements, default values, or wherever you need to capture timestamps. So we've learned that we should store our dates and times in UTC. But storing in UTC isn't enough. You also need the right data type. There are many date and time data types in different databases. The timestamp and date-time data types just store the date and time, but no time zone. Timestamp with timezone, or timestamp TZ, includes the zone or handles conversions. Here's what to use in each database. For Oracle, use the timestamp with timezone data type. For SQL Server, use the date-time offset data type. In MySQL, use the timestamp data type. For Postgres, use the timestamp with timezone data type. In general, you should avoid date-time data types or timestamp data types, unless you're sure you're only working with UTC data. Otherwise, you'll lose your time zone information. The exception to this is MySQL, where the timestamp data type can handle UTC conversion. You've stored your data in UTC, that's great. But now, how do you show the users the right local time? You need to know their time zone. In many cases, you can use a function or library in your application's programming language to convert a UTC time zone to a client's or a user's time zone. But if you can't do this, or want to have more control over the time zone displayed, or you want the user to be able to specify it, you can store the time zone for the user. If you've ever signed up for a community or a forum, one of the questions you may have answered on your profile is what your time zone is. This can be used to calculate the times to display on forum posts. To do this, you store the IANA time zone in your users table, or wherever is the best place to store this in your specific database. Don't just store +5:30 or -4 hours. Those break during daylight saving time and don't account for region-specific rules. Instead, use the full time zone name. Time zone names use an IANA time zone identifier, which is a string that looks like this, America/Los Angeles. This string can be stored to uniquely identify the time zone. There is no unique integer ID for this value, but fortunately, many databases can work with these IANA names. How long should this field be? The longest string as of the time of recording is 32 characters. Create a column in your users table or an appropriate table for your database and store this value. Then in your application, use a library or your language's built-in functions to convert UTC to the user's local time. Or you can do this in SQL. There are a few other warnings and tips I wanted to share. First, don't rely on your database server's time zone. It might change or be different in prod and dev. If you're grouping your data by day, always convert your timestamps to one time zone before grouping. Otherwise, you'll get inconsistent results. Watch out for daylight saving time transitions, which are when clocks go forward or backward for daylight saving. A time like 2:30 AM might not exist. So we've learned that you should store your timestamps in the UTC time zone. We learned to use the right data type for your database. Also, you should probably store the user's IANA time zone. Then convert the UTC time when it needs to be displayed. If you found this useful, I created a free SQL time zone cheat sheet. It compares data types, shows the right functions, and lists the gotchas you want to avoid. The link is in the description. There is another database design approach I see quite often, but it is almost always the wrong approach. Watch this video next to understand what it is, why it's bad, and several alternatives. Thanks for watching.